Hello everybody, this is Mr. Zabo. This first video for solving and graphing compound inequalities is going to focus on and inequalities. And inequalities will be written in one of two different ways. This is a compound inequality. They're always written with our less than symbols, and we have two of them, a less than and a less than or equal to. We know it's an and inequality because of the form this is written in. What it's really representing is that negative 19 is less than negative 3x plus 1, and negative 3x plus 1 is less than or equal to 11. So negative 3x plus 1 is being used twice, once with the negative 19 inequality and once with the 11 inequality. So you can set it up and solve them by separating them with the word and, or the other option is to recognize that, hey, I have my inequality symbols here. I've divided this into three different groups. So I'm going to kind of show it in both ways. So what we're used to is solving inequalities this way, in which case we would subtract 1 from both sides here, and in this one we would do the same thing. I can represent that by subtracting 1 in all three sections. So instead of just being like an equation or an inequality where you have to do the same thing to both sides, now I have to do the same thing in all three sections. And it's going to give us the same result. Negative 19 minus 1 is going to get me negative 20. I subtracted, so I bring my symbol down. My plus 1 minus 1 is 0, so I'm just left with negative 3x. Bring my symbol down, and I get 10. And I would have got the same idea here. Negative 20 is less than negative 3x, and negative 3x is less than or equal to 10. So back down to the bottom ones, if I were solving now, I would divide by negative 3 on both sides. But remember, divide by a negative, I take my sign and I switch it. Okay? I flip the direction of that sign, and I get negative 20 over negative 3, so that's just going to be 20/3. And same idea happens over on the right side. Divide by negative 3, divide by negative 3. I get x. I flip the symbol, and I get negative 10/3. And this is separated with the word and. To represent that in this form, it's divide by negative 3, divide by negative 3, divide by negative 3. But again, I divided by a negative. It doesn't change the fact that these two signs have to flip when you divide by a negative. So this becomes a greater than, that becomes a greater than or equal to. I still get 20/3 here, x, and negative 10/3. The hard part about a problem like this, that's the process of solving. If we don't flip our inequality, we're done. But because we flipped our inequalities, we're not done. We can't have these inequalities as greater than inequalities. The proper form for a compound inequality is to always have less than. So what we're actually doing here is, remember when we had something like 10 is greater than x and we had to switch it, okay, my inequality is pointing at the x. If I switched my x here and my 10 here, it becomes this. I'm doing the same thing, but I'm actually switching all three of these. So I'm going to put my negative 10/3 on the left, my 20/3 on the right. My x stays, but this inequality was pointing at negative 10/3, and it has to still. That gets moved all the way over to here and changes direction. This was pointing at the x. It moves over to here and points at the x. That is my final answer. Okay. I could leave this, or I could convert this as well. This is x is greater than or equal to negative 10. I want my smallest, or negative 10/3, I want my smallest solution here, and then it's x is less than 20/3. Same answer. Okay. On my number line now, I have my 0. 20/3 is positive. I'm going to put that in my numerator. Negative 10/3 goes in my denominator. And if I look at it this way, I have x is greater than or equal to negative 10/3. That's a closed circle. I could look at it this way as well. That's my left bound. That's why we have these less than symbols. The number on the left then becomes my left boundary. And then my right boundary is going to be at 20/3, and it's going to be an open circle, or I have x is less than 20/3. Less than 20/3 would graph left, greater than negative 10/3 would graph right. In this case, an and inequality graphs the middle. Okay. Again, I can show you separately. If I were to graph this one, that would have been closed circle this way. Graphing this one was an open circle in this way. Our solutions are always the boundaries and an intersection for an and inequality. The next video will discuss or inequalities.